Good afternoon, everyone. At least everyone's hopefully had a good lunch. My background is Satish Ramakrishnan. I'm an executive at MinIO. I've been in the Valley for a little over 30 years, mainly in startups, occasionally start things for large companies. Presto is near and dear to my heart. Prior to this, I was the VP of engineering at Ahana. So what do we want to talk about today? I'm not a sales guy. In fact, MinIO doesn't have any dedicated sales team. But what we do have is we have an amazing community. As an open source first company, we get about 1 to 1.3 million Docker pulls per day. We have crossed over 1 billion downloads, and we're used at over 10,000 corporations. So what that gives us is a very unique insight into modern data analytics platforms. So that's what we're going to discuss today. The key word in all of this is more. There's more data. Data is growing continuously. Your biggest asset is your data, and you don't want to have to choose which data you want to keep and which data you don't want to keep, because if you really want to find insights, you need to keep it all. There are more places. The modern enterprise has a distributed footprint, which means it is everywhere. It's on every cloud. It's on-prem. It's on the edge. It could be on factory floors. It could be on at 5G POPs. It could be connected, and it could be air-gapped. All of those data is everywhere. There are more analytic engines. Presto is the leader, but there's more and more of these analytic engines coming around. And that's actually good for competition. Great example is Presto, which we're talking about. And even more groundbreaking is all the Velox work that's going on. The most revolutionary part really is modern data formats, open data formats. With Iceberg, with Delta Lake, with Hoodie, you suddenly are no longer locked into a specific data format, and you can use tools that work across all of these. We're seeing them not only from the new distributed query engines like Presto, but even traditional databases like SQL Server and Snowflake are starting to support these. And the most important, more object stores. All of these, what ends up happening is that the only store which can actually handle all of these are object stores as a primary storage. So why are object stores becoming the primary storage for data lakes? They're highly performant, right? You can saturate the hardware at the network or storage level. The data, as more and more data comes in, it needs to be ingested at a high speed, and you need to be able to read and write at a high speed too. And that only object stores can actually get to that stage where you can take advantage of the underlying hardware. At the end of the day, we're all running businesses, so we need to scale not just technically and operationally, but we also need to scale economically. And that's really where it helps, where you can run it off of commodity hardware. No tiered architecture. I think the tiered systems are history. Metadata is really what's enabling technology, and that's, again, seeing it with Presto, we're seeing it everywhere where you use a metadata table store, and that's what's changing. It's not file, it's not block, it's all object store. While other stores can manage structured and unstructured data, they don't manage it well. It's not efficient. It's not the best way of storing those. The way the internet has grown and gone to internet scale is through RESTful APIs. As we get to the larger and larger analytic database, we're running into hundreds of petabytes or even exabytes. They need to scale at an internet scale, which is where RESTful APIs like S3 come in, and which is what object stores do. And coming to S3, just like Presto, the default uses the de facto standard, which is SQL. Object stores now use a de facto standard, which is the S3 interface. All the cloud providers, their primary storage is an object store. It can be AWS S3, it can be Google's GCS, Azure's Azure Blob. So there's a reason for it. Object stores are starting to become the primary focus for modern data lakes. Just wanted to give you a high-level landscape of what the modern data lake architecture looks like. It's an open architecture, so you have multiple querying engines, whether it's Presto, Spark, MinIO, Snowflake, doesn't matter. You have various table formats. It could be Hoodie, Iceberg, Delta Lake, and it could be any object store, which is MinIO, AWS's, GCP's, or Azure's. And it's multi-platform, and that's, I think, a big part of it. It can be, you can run it on-prem, you can run it in the cloud, and you should be able to scale easily. The most important part is no vendor lock-in, right? You shouldn't be locked into a hardware vendor, a software vendor, or even a cloud provider. You should be able to go across all of these. So what's the advantages of an analytical data lake based off of object stores? You should be able to write both your data as well as your metadata as a single atomic instruction. And so separating these two out means you'll end up with inconsistency. So it should be strictly consistent, and that's exactly what we do at MinIO. It has to be really fast, right? No additional layers which typically file and block have. You don't need ETL to move data around. In fact, at MinIO, we work at the CPU level. We use the SIMD instructions, so you pay no penalty for encryption, for erasure coding. It works all seamlessly throughout. The beauty is that you can actually scale compute and storage independently. So with Presto, you can, and any of these other engines, you can scale independently. And similarly, you should be able to scale. The object store. MinIO, you can start from you can run it on your laptop or a Raspberry Pi. We have customers who are already running it at over 200 to 300 petabytes. You have customers starting at 500 petabytes. So you should be able to scale out easily. It has to be able to run. It can run anywhere. It can run in public clouds, private clouds, on the edge. You can run it on bare metal, virtual machines, Kubernetes. Kubernetes nature, which is the best way of migrating your applications across. Again, the idea is that it is cost efficient. You should be able to run on commodity hardware. And more importantly, you should allow for lifecycle management, which says, I have a hot tier, cold tier, a warm tier, cold tier, and you should be able to tier anywhere. You should be able to tier from on-prem to a cloud storage, right? If you're on-prem, if you want to store it on Glacier because it's cheaper, you should be able to do that. And it should be transparent. You shouldn't have to worry about it from an application standpoint. And the most important part is business continuity has to be a first principle. You should be able to continue to run your operations irrespective of where it is. And so you should be able to replicate the data transparently to make sure that you can have active replication, active passive, and it should be across cloud, cross regions, on-prem to cloud, et cetera, on the edge. So quick summary, the world has changed. Data is everywhere. Multi-cloud and multi-engine data lakes are the new requirement. And Presto is key to that. To truly build multi-cloud analytics, you need a data store that can scale across all of these and give you that consistent performance. And only object stores can actually provide that because you can use any data format you want. So simplicity, the MinIO a binary is only 100 megabytes, so it's really simple. There are no extra layers. And that allows you to create architectures which allows you to be flexible, agile, and perform and scale at stage. And that is the modern data lake architecture. Thank you, everyone. Any questions? Any questions? My talk was that good? No questions? We're around. We're at the table. Again, we're also an open source project, so you can please come and try it out. Yeah? You have a question? Good.
What is the difference between MinIO and S3?
So let's little background. So when we realized that object stores were becoming primary stores. So we built an object store from scratch. What we did was we made its native interface S3, but otherwise it's an alternative. It's a drop-in replacement for S3, except that it can run on AWS, it can run on GCP, it can run on Azure, it can run on-prem. So right now we have 10 times more users than AWS S3 users have. In fact, people who are developing apps on AWS S3 actually develop on MinIO because you don't have to pay for the additional costs. So.
Anybody else? Any other? Hello? Any other questions?
No.
I have a question.
Yes.
How do people typically deploy MinIO? Oh,
so we have, you can actually download it from our site if you want to use it on-prem. If it's available on all the marketplaces, it's available on every single, it's AWS, GCP, Azure, IBM Cloud, Red Hat. If you're a Kubernetes, if you're on Kubernetes, we actually offer a Kubernetes operator, which will actually do all the work for you, including setting up the specialized CRDs, and it'll handle all of those. We actually have our own direct PV, which goes and handles those too. If you're on VMware, we are actually integrated in with Tanzu already, so you can use that, or you can use it with ECX. So we're available in any of those places.
Well, thank you very much.
Thank you, everyone.